Thank you. I have titled this presentation as Rewiring of the Real-Time Solution. As the technology has changed, we need to get aligned with that. My name is Robello Samuel. I am a technology fellow at Halliburton, based in Houston. Before that, I just wanted to give a brief background and punctuate it with a timeline that we are in. This slide shows the time versus knowledge, how the industry has progressed. You can see initially we drilled the vertical wells and started progressing, and we literally started punching vertical holes. Then the bifurcation happened. A lot of new tools have happened. A lot of new directional tools were introduced. That took the industry to the next level of horizontal drilling. Now we are literally punching horizontal holes. That is exactly we are in the bifurcation point. Now the next phase is the exponential growth in lockstep with the exponential technologies. That's what we call the cyber drilling system. That also in real time. Now, when you consider the exponential growth, it has to align with the exponential technologies that I call exponential surprise factor. Either we follow that exponential growth or we fall flat as in the previous cycles. Now, the fundamental question to be asked is, when does the bifurcation happen? When does it happen? The bifurcation happens mainly when the industry goes into contraction mode. So when you look at the number of rigs, that helps us a proxy to pinpoint and peg this bifurcation point. The first bifurcation happened during the 1984, the major downturn. After that, a lot of new tools were introduced. That took to the next phase. Now we are seeing this bifurcation point in another contraction mode. It's a protracted contraction mode the industry is seeing. And also at the same time, we are seeing the exponential technologies in alignment with this bifurcation point. Now, the contrary also happens. Right? When it is expanding, we tend to produce ineffective process, ineffective tools that we don't want to see when it is in the contraction mode. Now, I would like to take you through how industry in another phase is taking place. I would like to take you through two examples. One is the aerospace. A lot of changes are happening, removing the control structure, the physical structure, and moving to a cyber physical system. That is completely being rewired, where you can see the next one is the medical industry, where it is completely rewired. You can have remote surgery with advanced robotic systems, artificial intelligence, machine learning driven system. So in the previous example and this example, completely it is changing the landscape. Exactly, it is also in alignment with the exponential technologies. You see the telehealth, where we can see everything in the wrist, all the measurements. Now we wanted to take this type of technologies and see what is driving this technology. One is the sensors, devices that are advanced. The second is modern algorithms that are underneath this. Machine learning, artificial intelligence, ALML, all these things are deep learning or hand-holding it. Now, faster processing speed. The processes are much faster compared to the previous years. Apart from that, improved visualization. Take the results and quickly view it in different devices. Beyond that, they have advanced medical sciences engineering. That is important. That we should not forget. Now, can we take this telehealth approach to monitor the health of a well. So you can see the same approach that we can take it also. Now we have seen a lot of exponential technologies, the tools, AR, VR, but we have to use the science and engineering also. And we have to optimize the system so that we can take it not only on the wrist, but on the palm of our hands. So the complete system has to be rewired. That's what we call the well construction 4.0. Now, what is driving it? It is the same approaches: sensor devices, smarter algorithms, faster processing speed, improved visualization, and advanced well engineering. It is never offline, on the go, anywhere, on demand, that we can monitor and control the system. Now, when you look at the present real-time drilling scenarios, you have real-time centers where we can monitor using the software, real-time surface quality, data validation, or done manually as well as automatically. So you can see the operation center architects. We have different disciplines combined also. Sometimes on his own right, they can be analyzed based on the disciplines that we use. Now, we can take it to the office where people can monitor with a single screen or multiple screens, where we can see multiple screens. That's what the field and offices are brought together. And it also gives accelerated learning scenarios, where you can see multiple, multi-tenant, multiple rigs monitoring in a single place. It is becoming very complex because of the underpinning technologies and other things. So, but we have to take it to the next level, that we have to rewire it. That is the one that I am presenting. Bringing field to the office, office to the palm for quick decision, on the go, anywhere, anytime. So now, what is the economic value that we are bringing? Now, the system is evergreen, completely updated, using the digitalization, digital technologies. So in this process, you can see the interconnected system, where the surface equipments, the downhole sensors are all ingested. Then you can pass through the cloud technology or the local appliance. Then you take it to the server or the cloud, where you can analyze. Then you can send it back. It is a bidirectional system where we can control and steer. And also you can see other managements like fluid management, and ultimately this provides an opportunity for multi-objective optimization. Now, beyond that, a broader scope, which you can see here, it is a similar approach and a similar structure, but we want to analyze at a much faster pace. So you can see all the left side rig equipment data, surface sensors, downhole sensors, tools, and we have the edge devices. Also, we want to analyze at the edge. You can now have the capacity to do edge analytics. Also, then we can take it to the cloud for office use. So you can see different offerings like Dish and Space, artificial intelligence platform, and the engineering platform. Then you take it to the same similar approach of real-time operating center. Now it has the option to connect edge devices, IIoT devices, so that you can be evergreen. And also you can, as I said, it's a bidirectional. It can go back and forth. Now, wanted to particularly highlight this. That is the brain behind it. You can do all the analysis, not only at the edge, but also at the cloud. So both are in sync. Or sometimes you may not be in, you may have some problem in the connectivity, but you can still do it at the edge, then sync it up. So you can see here, the operating center now becomes a real-time office-related structural center, now becomes a virtual center, which can be on the cloud. You don't need the brick and mortar system, but it is all a digital system that are interconnected. And also, instead of multiple monitors monitoring several wells and several rigs, now it can be a single pane glass window that we can select on demand as we go and generate alerts. Not necessarily have to have thousands of dials. Some may not be useful at all. So automatically it will be guided intelligently so that the alerts are given. So you can set the threshold so that you can continuously monitor what is happening behind it. So that is a point that needs to be highlighted here. Now, what is the architectural stack? We have the digital well program, which is in short called the DWP, whereas two systems. One is the well programming, where you can program or in the planning stage. Then take it to the next level during construction platform that you are executing. And both are interconnected, and you can make the program evergreen as you get new data. So on the well program, you can see analytics engine, well construction, related things, plan, design, and also integrated with the supply chain. On the well execution time or the execution phase, where you can see real time, that is being rewired in such a way that you can do multivariate optimization on the go with the connection to different engineering microservices. That will take you to the next level of automation. So you can feed and give the set points what needs to be adjusted. And as I mentioned earlier, you have the edge analytics also at the same time, doing analytics and feeding and reinforcing the learning process. Now, you can see what are the engineering models. As I said, engineering models are very important, whether it is an aerospace or a medical industry. The medical science and engineering or aerospace engineering also improved or getting improved with advanced engineering models. Now we have well planning softwares, engineering software like the stress check, well plan, well engineering, calculations, and also cost analysis. And of course, the data storage related things, and the EDM is the engineering data model, over which all these engineering models sit on it. Now we can make all these things. These are made as microservices, and you can call at wish, and it becomes a system of no touch option. Now, summarizing, the same way that the aerospace is transforming or the medical industry is transforming, we are also transforming towards the well construction 4.0 in alignment with the industrial revolution IR 4.0. So it is from the rig to the cloud and to the palm of our hand. May look very complex, but underneath a lot of things, or it may be very easy to depict, but a lot of complex things are running behind it, as same as in other industries. With that, I would like to reinforce the model that it is and pinpoint the engineering models that are driving behind it. So that is important. With that, now we can see it is an artificial engineering intelligence. It is not artificial general intelligence, or not like a regular AI we talk. It has hyper time compression, a lot of data or pipeline in real time. Then we have to have extreme convergence of multiple engineering calculations with multiple objective functions, multiple constraints. And we need to have a digital mesh that are stitched together so that we have a science, engineering, and technology coupled, rewired system. That is what I call optimized, connected, on the go. With that, I would like to conclude my presentation and thank you for the opportunity to present what we are developing. Thank you.